Hi guys, welcome to part 13 of this series of videos on coding on a Dogen relational model. So yesterday we thought we were very close to getting our nightlies back up and running again. And we weren't too far off really. We're just having a look just before we started recording. And what you can see here is some good news, some bad news. We seem to have done only one build rather than two. We also seem to have had quite a few errors, and CMake also CTest seems to be a bit unhappy that we've got lots of files that are not committed. So we need to address these issues. So let's first try to remove the set this as unexpected, I guess. Remove this build. Didn't think it was remove this build that we did here. Mark as non-expected, that's what we need. So if I just mark this non-expected. So let's try to address the problems that we see here. Most of the test ran. Okay, so in terms of the commit, or the fact that there's loads of files that are sort of dirty in the repository, perhaps the easiest thing to do is to actually just commit all of the generated files, because I mean we only use this for the nightly, and the only annoying thing by doing that is that it's very nice to have the revision of the commits that we are building against. So I'm not entirely sure if we want to lose that, because then we're going to have a temporary commit that means nothing. And so if there's a problem and we want to know what commit caused the problem, it's not going to be so easy to find out. So that is an issue. I wonder if there's some notes on oh, actually we didn't check the other. Oh, and we also didn't build the other the reference model, so a few problems, shall we say. So what we need to do is, well, first we need to start clocking. Probably started it a minute ago, I guess. So if we look at cron, it's interesting. Perhaps the problem is we're out of sync with what's in Git. But as you can see here, we have experimental, we have nightly. And so that should have done its job. So I think we're just out of sync with the file that's in Git, so I'll just recopy that file and have a look. But meanwhile, more pressing is, are we going to fix this issue? Because we definitely don't want to see this error. So there was a way of saying oh, actually we can just look at the source code, I guess. Right, here we are. This is the key. If there are local modifications, then we just get that error. I mean, we could. I mean, the thing is, I just don't like red, and having things that are red are going to just going to cause distraction, because you're going to look at this dashboard, see the red, and then try to understand why this is red. So I think it's. I'd rather lose the commit, I guess. We could probably, without too much difficulty, retrieve the commit, because it would always be give or take with regards to the time of the build started. We'd be able to pinpoint the commit. So I mean, the world is not perfect, so unfortunately sometimes you need to make these decisions where it's a bit of a trade-off, really. And so what we'll do is we will just do a git commit here, and what, for good measure, what I'll do is I'm gonna have a quick look at our previous experiments. Sadly, I don't think we checked those in. It was a mistake, really. We did a number of experiments with commits. Doesn't really matter. We will just, after the generate all files, we just do a git add -a git commit -m generated code. Okay, so in theory this is now going to give us generated code and a commit, so CMake is not going to, CTest is not going to be so upset. Also, the other interesting thing here is if we just jump over to the nightly area. The other interesting thing here, let's just open up this cron that as you can see here, we attempted to run 2 builds, but for some random reason we didn't. I'm quite curious as to why that was, because I can't see why we wouldn't. Let's have a quick look at the logs. So if I look at GCC 9, so we submitted for GCC 9, so okay, fine, understood. But Clang 9, bingo. We attempted to run for Clang 9, but that failed miserably. Okay, so yet again, our ID disappeared. So because of that, we need to, well, let's just double check 2 things here. First, ctest.cmake and Clang. Right, as you can see here, we do not have an entry here for Clang 9. This is actually not a very nice thing, because every time there's a new compiler, you need to go through this pane. It'd be nicer if we didn't have to do any mapping. And the second thing is, just for good measure, we should double check that build Linux also has Clang 9. Okay, it does. Now while we're at it, let's do a similar exercise for the reference model. It also lacks Clang 9. Okay. So at this point in time, we have got Clang 9 in both. So just ctest at Clang 9 compiler, and we just go back to this chap here. Similarly, we add Clang 9 compiler. You could also say scripts commit the generated code in nightly builds. Right, so that's our first 2 problems. The second problem is we seem to somehow, I'm not sure how we did this, but although we did all the hard work for syncing up generation.cpp, we seem to somehow have not committed that to master. So some distraction here. So if I go to generation.cpp and if I just look for okay, we can't do it from here, we have to go to the nightly, of course, because for some reason nightly doesn't work on the completion. So if we go to, in fact we should probably start deleting some of these directories, so generated is not needed anymore. Dogen pristine. Okay, cool. And in addition, we must make sure that pristine is deleted, which is correct. So now then, if I go here and into Dogen CVP source serialization generation. Right, I can hear a lot of noise downstairs. Let me just pause for a second. Right, sorry I had to pause the video for a second. I'm actually a big fan of this pause feature in OBS. It's very convenient. There's always something happening while they're trying to record. So as I said, we forgot somehow to add the linking references to the generation project. I thought we had done it, but clearly I must have skipped it somehow. So we're missing tracing, generation, variability, and archetypes. So I was pretty sure we had done this, but sadly I think the confusion was that we probably did it the nightly build, and then because of that I assumed we had done it in the main, but we didn't. The build succeeded. Okay, so I don't think, at least you can't see any more errors here. And of course we are running as experimental rather than nightly. So pretty much all the problems we had for the nightly are addressed with these changes. So all we'll do is we'll just well, we can leave this build here, to be honest. It'll be good so we can compare and contrast before and after the fixes. So tomorrow we will have a nightly that hopefully will take into account all of these problems. So let's just commit that, and that's our work today for the nightly. And I probably would at this point consider this story done, but we'll just wait until the build is green. This makes more sense really. If I just say something like CMake add missing linking, missing libraries to generation linking. So add missing libraries to generation. So perhaps link missing libraries in generation. Okay, and so with this we more or less completed all it. No, of course, the most important thing of it all. We need to jump over to the nightly area. Should also close some of these nightly related buffers, and just leave us here in nightly. Oh, not quite there. Just leave us here nightly with a shell. Right, so this is nice. And then if we just do a CP again, and just for good measure, let's just have a look at the copy, make sure we haven't forgotten something. So as you can see, yes indeed, nightly, the logs, everything is executing, looks quite nice. Okay, I think we can now consider this story, well, as much as we can do for now. So, well, this has been one big parenthesis in this task, so much so that I can't quite remember what we're trying to do before we fix all these problems. Oh, another thing we probably should do as well, should just have a quick look at the general status of the world in terms of builds, because expecting a bit more greenery really. We had that massive drop of 10% coverage that we still can't explain, but I'm not going to waste too much time with that now. We'll just have a look at what the builds look like. So as you can see, the general scene of the builds is much better now. They're all well below the 50 minutes. All green. And the same thing for the Limple. All green and all below 50 minutes. So that's kind of like the objective of this task achieved. Because as I said, we couldn't really continue to do some low-level refactoring of the system if we had a lot of red things. Similarly on Windows, we also much quicker. MSVC still lags behind a bit, but And of course, you have to remember that some of these builds are not building the relational model, but there we go. Similarly, all green here. So at this point in time, we're in a good place to continue the real work. It's very important as a developer to always start from a known good state, because if you keep building on top of things that are not quite right, then you're just going to end up with trouble. I feel slightly tempted to try to upgrade to GCC 9 and Clang 9 as well, because often we get some speed improvements with the compiler, so it's always good to be in the latest version of the compiler. And since it's all backwards compatible, I think it's actually just a very, very tiny change to the Travis file. Let's just double check. In fact, it's not even the Travis file, I think it might even just be the build scripts install. So if I look at the... So as you can see here, we are installing Clang and choosing a version, so I think it might be as easy as saying Clang 9 and GCC, well, GCC 9 we have already, can't go much further than that, so GCC 9 is good. Not sure why I thought we were on GCC 8 actually. See, we still refer to GCC 8 and Clang 8 here, but if I go to the compiler, it's GCC 9, so we just on Clang 8 but GCC 9. Okay, so let's just try, this might be trivial. Bump Clang to 9, and then if we could, so in the C test presumably, we want Clang, okay, no, not quite C test, presumably in Travis, when we call out, we must choose the version of Clang. Well, we only say Clang rather than Clang version, oh yeah, bingo. So here we need to say Clang 9. And hopefully there will be no references to Clang 8. No, okay. So what we'll do is, for good measure, we'll just bump compiler version. And that's just it's two steps. First we need to make sure we install the right version. Second, we need to make sure we call that. Consider this is also to do with the build. I mean, it's not exactly the right. Sometimes you have tasks like these that are so small that, although having said that, I think we may have a story. No, we don't. We don't have a story for Clang 9, so we just bundle into this story. So yeah, sometimes you have these micro stories that is just not worth your while creating a story for something as small as this 5-minute job. So all you do instead is you just add to the whatever nearest story you've got, and in here you can just say Travis scripts bump Clang version TV9. And since we're doing this here, of course we should always keep the reference model in sync, which means we should update both both the version installer and the Travis version. So if I just look for Clang 8 and replace that with Clang 9. So a bit of luck. And for good measure actually, let's see if this readme. Okay, it does mention the version of Clang, so let's just say Clang 9. And then we have a link here. Let's go to, let's jump over to web. It's interesting that we don't seem to be able to resolve as we used to in the past by typing the name of the space. Right, so if I just update this to point to clang 9, I wonder if this will, it does the right thing. Cool, excellent. So let's just change this to 9. And for good measure, we also have GCC here, which is also GCC 9. Again, quick check to make sure this link is valid. GCC 9. So we updated these. I think we're good to go here. So if I just unclient version 2v9, and if we just resume updating, there we go. So we need to update all of these. I think I may have forgotten one. As you can see, the CCC was already GCC 9, so the other one was lagging behind. So what we'll do is just uncommit or get committed. Make sure the backlog reflects this work. And commit this again. Now I just want to double check that we didn't forget to update, and we did. The badge itself. So similarly we need to uncommit this, commit the whole lot, update. Okay, so what we'll do now is just jump over to Git for the ref import. I'm just going to trigger a build now because I want to see if this update to Clang works or not, and this always takes a while, so we commit the ref import first because it's faster. Okay, cool. Okay, so with this, hopefully we're done with the work of the build. Can focus on slightly more interesting things. But I want to stress really that this kind of work is what makes OverX a project. It's very boring. It is extremely boring, but you need to make sure that your CI is always reflecting what's happening in the real world. Because if you, it's a bit like being a pilot, I guess. The CI is the feedback you get. So if your CI is not giving you good, accurate feedback, then you can't really rely on anything really. You need to have tests, and you need to make sure you run them for every commit, and the build should always be green. Even though this is not the most glamorous of work, but it has to be done, else you're diving blind really. So now that we've done that, we need to focus again on our lovely relational support model. Relational model. What we need to do is let's just close some of these guys. Hopefully you don't really need to worry too much about them. In fact, to be honest, as I said before, I recommend closing all models every so often and just starting again. I mean, it's very boring, but we've had far too many problems where we ended up doing saving over an older version of a model over a newer version, and then taking ages to discover what was the problem. That was rather wasteful. So then, given that we have a relational model here, and we just need to put our heads back onto this relational model. So we probably lost a few minutes here, so this should be 25. Right, so the objective today is to see if you could start to make use of the relational model. We really need to get our heads around again what we're trying to do here, because it's been such a long time since we looked into the relational model. Let's have a quick read at the story, just to see what we were doing at the time. So whenever we run into a problem, we seem to spend a lot of time going through the log files and trace files, trying to figure out where the problem is happening. So yeah, this is exactly the kind of problems we faced such as, for example, when we had problems with login configuration. So having a go in trying to implement a relational model for tracing, so have a quick go, it's not the best English, to see if you can transfer the bulk of the data into a relational format which can query via SQL. Now, of course, we've created a basic relational model for tracing. The relational part of it seems straightforward-ish. The problem is the integration of the tracer with the relational model. Okay, so that was all that work that we needed to do in order to integrate the tracer. And if you remember, if we go up to the tracing model, at the moment the tracer doesn't have a notion of a backend, so it's just a file backend which is tightly interwoven with the tracer. And due to that, we can't really say, okay, write to the database instead of writing to a file. Okay. At present, rely on the fact that all traceable objects have I/O enabled. This works because the code generator creates I/O facet, which is then used by the write method in utility to convert any model type to a string. However, we now need to change the approach. We need multiple tracing backends. Exactly. So we need a file and a database. The file trace is more or less the current tracer. The database tracer needs to decompose the objects in existing models into a relational representation. In an ideal world, the user would configure the tracer to use one of the two backends, and the remaining usage would be transparent. However, we cannot have an interface with a tracer backend that uses template methods because we need virtual template functions. Okay. Another alternative is to make use of the tracer, is to make the tracer aware of the model object it's tracing. This is also not ideal because we would create cycles in the design. Yeah, we don't really want that. In effect, we need to somehow implement a similar approach to the existing tracer, relying on global template functions, operator inserter to decompose the objects to their relational representation and then supply those to the backend. It's not very clear how this would work. For now, we need to postpone. Now we postpone this approach till it's not going to be a quick win. So we need to approach this incrementally. Next time we have a bit of spare time, we need to generate the model and then create the adapters from existing models. Finally, we can look at how this will be integrated with tracing. Okay, so this sounds a sensible thing to do. So, to summarize what we just read, the problem we have at the moment is the tracer is dumping all sorts of objects of different kinds, and we're relying on this template. And the idea with the template is that provided that you are I/O, or provided you can convert yourself to a string, then it doesn't care what object you are. This enables us to have the tracer with very few dependencies, because we don't need to know what we are tracing. We just care that it's convertible to a string, which is fine. However, the problem then is we can't really do that when we're talking about a relational model, because there is no equivalent way of converting a model into a relational representation. I mean, we could potentially have a function that does that, but it seems to me that it would make more sense to have a function that does the conversion first and then call the tracing with the output. However, then we need two different interfaces, one which is a string-based interface and one which is a relational model-based interface, which is not ideal. This is what the notes were saying. So, if we had the adapters, and if the adapters lived with the models, so let's make this a little bit more concrete. Let's imagine, for example, the variability model. Let's imagine that we're trying to trace the variability model, and I have somewhere something such as a configuration, or not sure what the entry point of these traces are, but say a feature model, for example. So what I'd need is a way to say, trace the feature model. This will then create the relational representation of the feature model, and that relational representation then can be used by the tracer, because the tracer would have a dependency on the relational model. So the input here would be a model in relational format. However, if we do that, we have to choose between one or the other. We either are relational or we are string. We can't be both. Yeah, here we have input. So that's a problem. Not entirely clear what the best thing to do here is, and clearly this is why we postponed the thinking for this, and we said, well, you know what, definitely going to need some adapters, right? You need to adapt model to a relational representation. So whilst you're thinking about how to address the problem of the tracer, why not just create the adapters? So that seems to be a sensible thing to do. Let's see the rest of the notes to see if there's any other clever ideas here. North wind tracing. Okay, this is problems we had faced in the past. Problem arise with primitive properties. Okay, this is all the problems we had trying to generate the model. It seems foreign key. Okay, we don't have foreign keys. We need the command line option that chooses the tracing backend. File database. Fine. We need to refactor tracer as follows. So update the tracer. Right. Presumably this failed because we can't update the tracer to take types because we would have a cycle, in the sense that tracer is used by every other model, and if it requires every other model, then we have a cycle between the two, and as you remember, we can't do that. What we need to do is perhaps to overload. See, clearly the key thing here is we're trying to pass in something into this function, and we want to say if tracing is relational, then we'd like to convert this into a relational model. If tracing is string, we'd like to convert this into a string. Now, we could still have a template function, and we could have the adapter as some kind of overloaded function, rather than, and it's the responsibility of the caller to call the adapter. Yes, that's exactly right. Okay, so we have an approach here. So this will remain a template function. It will be an IOable or relational. The template function will do an if based on one or the other. The caller is responsible for including the adapter. And then here, all we need to do is to worry about the relational model. And that means we'd only have to have a reference to the relational model, which is good. And then we can direct that to the right backend. So let's start this work then. Though I think perhaps we could start with this, but the key thing is going to be that if we do not have adapters for every single one of the things we're calling the tracer for, we will probably have some kind of error, some kind of compilation error, right? Because at compile time, the compiler needs to see an adapter in order to for the code that does the, I guess you could call it the dispatching to the right conversion function. It needs to exist, the conversion function. So we know for sure we're going to have to go through some kind of so what we'll do is let's start with at the bottom of our graph, which is variability. So put my coding gloves on. So today hopefully will be more of a coding session rather than a build related session. Although before we go much further, let's just double check that Travis is actually not failing. No, and it is. Seems like we probably, to be fair, we probably should check that apt repository contains Clang 9. Not to worry. So what we need to do here is need to locate the install script, which will be here somewhere. Travis YML. Here we go. So around here, we must have must be calling Travis.install, and I bet you have an error somewhere. Okay, some kind of warning. Failed to fetch trusty. Oh, that's very interesting. That's extremely interesting. In fact, we should probably not be calling trusty anyway, because we're now in Xenial. So that's definitely not a good idea. Okay, what's this trusty 9? I wonder. Was this trusty 8 prior? Yes, okay. So I think we've done something silly here. Okay, first I'm not sure we are talking up to trusty because we're in Xenial now, so that's the first problem. Second is, it seems like they didn't create a 9 version. So let's just have a quick look at this, see what we see here. So everything here seems to be trusty. Okay, well, fair enough. Oh yeah, so it seems that we don't really have trusty 9 yet. So what happens if we try Xenial? Okay, excellent. So this is much better. Okay, let's just have a quick look at our script. Sorry, we're gonna have to yet again pause this task, quite sadly. So let's go to our install Travis script, and what we see here is we need to update this link. So probably the best thing to do is to say distro or version, distro version name, and in here we should now say Xenial, and we just update this, and where we have trusty, we should say, maybe we should even call this release to be honest. And this could be toolchain maybe, and then we want this to be Xenial. Okay, now hopefully what we need to do is to assemble the URL. So wherever we have the word trusty, we need toolchain. Version is probably fine, server is probably fine. So let's look at this more carefully. Version, of course we want version 9. Xenial, which is the distribution, release. The server is apt-LLVM release. apt-LLVM release. But notice that it says dists. Xenial dists. But I think it's fine because we are just generating a dep command line, so it's fine. In the toolchain, and I think we're done with this. That's about right. Similar exercise needs to be done here. Nope, not the toolchain one. what I'll do this time is I'm going to paste this here so I can see the differences. So we're trusting our server. Looks about right. Let's give it a go. So since we're having problems with the build, what we should just do is, we know this is not going to work, cancel all of these builds. Particularly want to cancel the Windows builds that are not really relevant. And similarly, Dogen builds can be cancelled. Okay, so now then, let's see stuff like this. Scripts, fix, Ubuntu, update Ubuntu version 2.0 for LLVM. Packages. Okay, that seems vaguely sensible. And if I just jump over to Git and push this guy. Because I'm feeling confident, I'll do exactly the same thing for this chap. Let me just push. Okay. So now then, whilst we wait again for these builds, what we were saying was we need to create a whole load of adapters. And sadly, none of this is going to work until we've done all the adapters, because we can't just do one adapter and test it. We need to at least have the adapter, even if it's not adapting much, but it needs to at least exist, because as soon as we change the tracing model to have the relational logic in it, it will require every call that is at the moment using an IOable. It will also need to support relationable, you see what I mean? So therefore, and the other interesting thing, of course, is that the function that we use to adapt has to be global. Now I understand my own comments where we're talking about a global function. We needed something global, because if it isn't global, if it's got a namespace specific location, it will not work in a template with a template. So for example, operator, so if I make this slightly more concrete, when I define something like operator inserter, operator inserter is global, so that if you do A, B, operator inserter will work because this is defined globally. But if I was to define something like I don't know, A, B, C, a converter in ABC, then well, it will work fine until then we have a Z, Y, W converter. Because they're in different places, then I'll be calling one of these, one of the two, and I need to call the appropriate one depending on the type that was passed in as a template, so that's not going to work. So what we need is a function that is defined in the global namespace, just like operator inserter. A function could be called, for example, to relational model, but the crux of it is it has to be declared globally. And it has to be overloadable. And then once you've got that, then you can just call to relational model of T, and it would always work, provided you've defined a to relational model for all T's. And that's fine, you can do that. So the way to do this then is to start model by model to define a relational converter. First we need to add a dependency to the relational model, which we can do here. And reference consideration relation, because the good thing is, or what we'd expect is that relational depends on nothing, not even tracing. This is important. Okay, we have a problem here. We're relying on, no, this is MASD variability, not Dogen variability. So this is sort of the global MASD level model. So as you can see here, we don't really rely on any model other than profiles. So that's good. Now then, we start by relying on this model. Then we can, in our helpers, we can create something here. It will be handcrafted. You can call this relational adapter. And what we want to do with the relational adapter is to have something like an adapt. And then here we want to say, well, whatever the model is. And this is the direction it's going to be in. And the output, well, now this is where so meta model, feature model. This is where things become interesting. So we're going to have to, for all the types in this model, we'll have to overload them. And finally we want to return something like, I'm not entirely sure what we're returning. Let's have a look. We shall be returning something like relational tracing. Part of me actually starts to ask whether it wouldn't make more sense, instead of having a relational model, to have a relational component to the tracing model. And because in reality we're going to start bundling all sorts of functionality in the relational model, all to do with database. There is something to be said really to keep the types close to the non-relational representations. But we'll leave that question for later, needs a little thinking. But what we really want for the purpose of this current exercise is to say relational tracing model here. So this guy is going to basically adapt a feature model into a relational model. And we probably need some kind of adaptation error, I guess. Now this is not particularly nicely lined up as we like to keep our models, so let's figure out where is the best place to put this type. Perhaps you can go down here. One thing we haven't done yet is we don't really have sort of a global exceptions that we just use. So we are defining exceptions everywhere. So you see that there's an adoration exception everywhere, and at one point you need to clean up these exceptions and just have a smaller number of exceptions. So we're just being lazy. There's so many cleanups that are required that if you were to start doing these, we never finish. So we could say that there's an adaptation exception. Last adaptation model. Right, so most likely we will have to throw something, so and what we'll do is for a good measure is get these chaps to move a little bit. There's plenty of space on this side. If you just execute our Python scripts, get some colors. So the relational adapter will adapt a feature model into the relational tracing model. And what we'll need is we'll need one of these per thing that we're adapting. So unfortunately we're only going to find these out once we get to the end, but so a bit of guessing is required here. And we have a feature model here. We also have this configuration type. I wonder how the configuration type is represented in terms of the relational model. because it would be nice to just dump this into the database, wouldn't it? So we're focusing more on transforms. Yeah, as you can see, we don't seem to have much of a representation of a configuration. However, nothing stops us in treating configuration as an attribute. So I think we probably will need, when we're dumping, say, an assets model or an injection model, we will need to represent configuration as something in relational model. So for good measure, let's just also add adapt. We don't know what we're going to adapt it to though, so we'll just leave it all that for now. We'll just put here something like meta model configuration, and then the result type we don't really know, so let's just call it fix me for now. Okay, so that seems like a very simple relational adapter. What we can do as well is just to make sure that we're in the right ballpark. Did it push everything? Yes, we did. Make sure we're in the right ballpark. We can just quickly see where the tracing is happening with the variability. So let's say, for instance, coffee is getting cold. So tracing is a transform concern. So what would happen in transforms? And we'll do it in chains. Right, here we are. And you can see here, we don't actually, we are dumping the feature model. So that's good. And these guys here, we are dumping the feature template repository. Actually, one thing we could do, interestingly enough, is we could create a set of new methods, I guess, that we only use for the types that we're covering. So for instance, we could say and transform new and start transform new, and these new methods will do the new logic that calls the new adapters. So this will allow us to test things as we go along. So one of the things I profoundly dislike is any effort that cannot be tested iteratively. So if you're going to do something that requires you to do hundreds of lines of code, or even more probably, before you can start to see the results, then it's probably not a good idea, whatever it is you're trying to do. It should always be possible to do some kind of test that gives you some idea of which direction you're going. And so even if it requires some hackery, I guess, you should always be able to do that. So that you can progress iteratively. So what we really want to do is we want to start writing these models one at a time to the database. So we will create these new methods such that we can literally do one model and then move to the next one. Now as you can see, there's very different kinds of types that we got here. So a feature template repository, for example, doesn't seem like a model. Don't quite know what we're going to adapt it to. If we look at variability representation of a repository, feature template repository, just a series of templates. These templates can probably be represented by attributes, with a bit of luck. But literally, I think that each of these things, this adaptation is not quite as simple as it may appear. I think for each of these we need to think about what we're doing. So this has to be iterative, really. It's going to take us quite a long time to adapt everything correctly. We have to preserve the data in this adaptation, so it has to be something logical. So what we want to do then is we want to say, in tracing, we need the file backends that is an interface based on strings. We need the relational backend, and then we need the new methods underscore new, which will take IOable and traceable, and we will update one at a time. So that is the right logical thing to do. So we'll leave our relational adapter there because that's a good thing. But what we'll do is we'll start with we will start by creating a file backend and relational backend, and then we probably well, for now I guess we just need to write numbers. Maybe we need the start, so we'll need something like a start transform, and we'll need something like a finish and transform, something like this, right? And we don't really need a lot of state in these guys. An attribute, an operation. So let's start transform and then end transform. Right, so I believe when we created the configuration for Dogen that we already covered tracing backend, file and relational, so we don't really need to duplicate that. It's quite a lot of noise going on still. I think it's building work going on. Hopefully it's not going to interfere too much with the sound of the recording. So the tracing backend already has file and relational database. So in the tracing we just need the two backends. We will have the new methods. I'm not going to bother to update this interface with new because it's just temporary. We don't quite know exactly how the start and end transform will work, but we'll have those in a second. Probably wants to reflect the fact that the tracer is using these chaps, so what we'll do is we will, well actually let's just be a bit lazy and make the references in here. I quite like diagrams that reflect the structure of the objects. I mean, I think creating diagrams is a bit of an art rather than a science. What you do really is you try to give some detail so that the reader could look at the diagram and have some idea what's going on. But because the diagram is a model, it necessarily can't be complete. It doesn't give you a full picture of reality, but it should give you some idea of how these objects are related. So that if you look at the diagram, you got some kind of the gist of the code. Righty, so file backend, relational backend. And to be fair, we could probably update all the methods to use the file backend right now, because that is completely interface compatible with the existing methods. This will just take a std string, and in effect will probably be, interestingly enough, I wonder if the backend needs to know about start transform and end transform. The relational one sadly probably does, because the relational one, depending on whether it's a start or end, the relational model will write to the database differently. So we must have some kind of way here saying what is at the start and what is at the end. Not entirely obvious. Some of these things really, what you need to do is you need to actually start making use of things, because it's very difficult to, it's just too much abstraction in your head until you start coding. So it's good not to model too much without coding. Because sometimes things look great in the model, and then you start using it in practice and you figure out there's lots of problems. So I always recommend you do a little bit of modeling, but not too much. Otherwise you might just waste time. I can't really see how the start and end transform map here. Ah, here we go. IO type, input, output. Presumably this is to reflect the start and end. So we could have a right input and right output, perhaps. Because from the point of view of a backend, I mean, we're not really starting on any transforms or something like that. Ah, but there is another problem. We need to know if that input is a chain. Oh, what do we? We probably do, because we need to manage the path of where we're writing. So chains, the difference between chains and leaf transforms is that the chains result in folders when you're using the file system, whereas the leaf transforms just result in files. So presumably all the logic of managing the creation of folders and so on should really be part of the file backend. So really, the more we think about this, the more we're saying is something like, perhaps we should just delete these guys here, and we should just start with this guy. And then what we're saying now is this: you're no longer templates. Not entirely sure if you need a tracing configuration or not. I'll leave it there for now. And you sort of have to more or less cover all these things, except where we had eyeball. We just want a string. And now, as you can see here, these directions are always in. Right, so what we've done here is we now said, well, if you're using the file-based backends, you must supply it with strings, because that's all files now really. So it's your job to make sure it's in the right format. So we trace it in. So then I guess what we need to understand then is, before we go much further, is let's understand how much stuff is really tracing, and how much stuff is actually backend. Sorry. We need to understand how much stuff is tracing and how much stuff is actually related to the backend management. That's, I think, where some confusion exists at present. Let's keep an eye on our builds. No client yet. Okay. Seems slightly happier now. It's good when you can upgrade compilers and it's just a 5-second job and things largely work. Now I suspect this is all the errors we had a second ago. And 9 missing. Since we have so many builds, let's just get rid of most of these. As you recall, we cannot have too many C- builds. There's a limit in the free edition, so keep an eye on the builds. Otherwise we start to having builds that are rejected by C-. And we didn't even notice this, but it seems that we succeeded in a nightly for the reference model, but interestingly enough, we don't seem oh yes, of course it was because of the Clang 9, so that's correct. And as you can see here, because we didn't do any craziness with the files, this is fine. Right, so what we'll do here, as usual, is remove all the other builds. It'd be nice if you could just mark the builds and remove all in one go. I guess they didn't think people would be removing builds manually on a daily basis. We already are 1 hour into the recording. Where are we? So I just remove a couple more. Again, this is not an exact science, you just need to remove a few. This seems to be like a new one, so we'll leave that one. So then, what are we trying to do here? We're trying to say, that tracer has two roles. One is the interface for the tracing system, but the other side of it is managing. It is actually managing all the directory stuff. And sadly, file system stuff, so sadly we don't really want that to be the case. Because of course if you're in a relational model you don't have to do that. We do want the metrics builder. Interestingly enough, we haven't yet covered in the relational model anything to do with transforms. Presumably it's not a problem because you can always infer from looking at the transform components all the stuff that we see in the metrics builder probably is there, just not in the same shape as metrics builder. Which makes me wonder then if we should really be doing any of the metrics builder work. It seems to me that all of this work is file based, and the tracer is going to be nothing more than a dispatcher that just chooses one. Yeah, so really, let's just rephrase this. What we're saying is there's no such thing as a file backend actually. There is a file tracer and there's a relational tracer. The tracer is a dispatcher to each of these implementations of the tracer. And what we'll do then is, because these guys are so big, I mean, I dislike the fact that this thing is going to be almost a copy of that thing. In object-oriented terms, really, what you do is you'd create an interface, iTracer, like if I was in C#, and then I would create a file tracer. But of course, this is C++, and you have to remember that we're using a lot of template stuff here, so we don't really want to start enforcing that kind of rigidity, because it doesn't play so well when you start messing around with templates. So really, instead, what we're going to do is we are going to logically, this is correct, so all these details are correct, but I mean, it's just a pain in the backside to duplicate all of that, and you get the gist of it. So I'm just going to create a file tracer, and I'm going to make the file tracer interestingly enough, if the tracer is printable, the file tracer has to be printable as well. Or even better, perhaps we want... Yes, this is the problem. We don't really want a lot of state, because if we have state in the tracer, then we have a problem. So, because we don't really want to have a file tracer and a relational tracer if all you need is just one or the other. So at any point in time, you're never going to have both a relational tracer and a file tracer. So what will we want to do here? Slightly confusing. We could of course just have tracer containing one of these, or both of them actually. Let's just put the names down. relational tracer. So as you can see here, what we're trying to do is trying to say, right, the tracer contains both the file tracer and the relational tracer. Now, as you've seen already, we need a lot of state for the file tracer because this is a file tracer. In fact, what you've seen here is a file tracer. This implementation here is of a file tracer. It will be identical to this. The only difference is we're going to take away all the templates. Similarly, with the relational tracer, where we need states, such as, for example, the database configuration and so on. And we will have a database connection perhaps as a state, and so the tracer really has to have these chaps in memory. And of course we have to remember that it is possible that the relational tracer is not available. You may have had a build that doesn't have a relational tracer, so if that's the case, we want the code to simply say don't do anything to do with relational tracing. We could hide that in the interface. We could say that there's a null relational tracer. And we could say that there's an actual relational tracer. And depending on whether your build was had enabled relational, it will allow you to instantiate the actual relational tracer, or it will always just give you a dummy relational tracer. I mean, really, you wouldn't even actually go that far because you wouldn't see that the option exists of the relational tracer. Because it would be behind a macro, so that's fine. But I can't think of a way of doing this without having a lot of states, which is a shame. Okay, so sadly that's what we're going to end up having to do. Let's just do this for now. Again, like I say, in IT, this is a very important point. In programming, it's very easy to make really complicated sort of designs and have really deep thoughts about something and how something ought to be. But you have to remember, at the end of the day, this is fundamentally an engineering exercise. And engineering is really all to do with doing, not so much with thinking, not so much with abstract models. Engineering is really where the rubber meets the road. So it's much more important to actually do something. Doesn't matter how bad it is, just to get a feel for what exactly happened in the practice. And then once you've done something, then you can start to make it better. But if you start off by trying to do a very complicated thought experiment of all the permutations and possibilities, you will end up probably not really coming up with a particularly good idea. You will miss something, and it's not really going to be helpful. So in that spirit, what we'll do is we'll just come up with a file tracer, and we will just almost literally take a copy of the existing tracer, implement it, and then we will tackle the relational tracer. So we'll start with that. So what I'll do is I'm just going to generate availability. Let's keep an eye on those builds. Not too worried about Windows. In fact, let's just make sure that we don't have too many builds on Windows. That's good. That's excellent. So we have one per project, and this looks very good. So we are now on client 9. So let's just have a quick look at what's okay, this is excellent. So builds are starting to come through. They look good. Okay, so we can leave this alone for now. Let's just experiment the way we had earlier. Hopefully we start to see some of the gen builds soon. Righty, so we've generated something. Like I said, at present we don't really have a proper skeleton, I guess, support. No, actually we generate the variability. What I really meant to do is generate tracing, I think. But that's fine because we generate both. And there we are, we have our tracer, and it does some I/O, which is what we wanted. Right, so one thing I tend to do is I tend to actually just commit generated codes as soon as it comes out of the generator. The reason why I do that is because it's a good idea to just see things changing incrementally. Interestingly, we don't see. Expect that to have changed. Oh, we did. We don't really need that model open anyway, so and if we do something similar to variability, so we just need to convert and then indent, and then remember not to okay, so this is actually, just have to be very careful here. We just added a new reference. And so what we need to do then is to make sure this reference is there. And I guess we would have something similar for tracing, although I don't think we added a reference just yet. But we know that reference is coming, so there's no point of postponing this. Dogen MASD.injection reference equal to Dogen.relational. Okay. One thing I find difficult sometimes is when you're focused on one objective, just tracing, and you really got your head around it, and it's kind of, and you achieve that, and then you have to get your head around something else. It's find it difficult to context switch from the previous problem to the next. First takes me a little while, and then of course a little bit later the brain just goes into gear and you get on with it. For the first few hours it's changing from one problem to another. Always takes me a while to get going. Okay, cool, so that's good. So like I say, I think it's a good idea to commit, even though you'll say, oh, it's a bit silly, you just generated a whole lot of code that doesn't have any logic in it, it's just skeletons, and you're committing like that. Well, I prefer committing that kind of code because so in fact normally I would even say commit the model separately, but in fact to be honest, that's exactly what I'm going to do. Sorry, I don't think it's a good idea to make commits that are too big. So if you change two models, my theory is that you should commit them separately. So variability and relational generate, really, because we didn't really add any logic. So we generate relational adapter, and then for good measure tracing, generate file and relational tracers. Yes, like I was saying, I believe in these sort of very incremental commits that capture every single state transition of your code. You may think it's a bit boring and a bit too detailed, but what I find is if you do that, then when things go wrong, you have to think, what's the point of history, really? The point of history is to allow you to, whenever there's a problem, to allow you to figure out what the problem was very quickly. And if you skip too many steps in your history, if your git commit is a few hours, a day or two worth of work with one commit, what will happen is you would have a lot of things in that commit, and then it will be very difficult for you to unpick things when things go wrong. Whereas I prefer to do lots and lots of little assertions, like as they said in La Haine movie, jusqu'ici tout va bien. Up to here everything was working, and then that's what every commit is in this system. And you should be able to just look at the commit message and say, oh yeah, okay, I got the gist of what he was trying to do here, because each commit is just small and incremental. once you start bundling too much functionality in each commit, then it becomes difficult to make those assertions. It takes you longer and longer, and so that's not a good thing. Right, so what we're going to do now is we're going to take almost literally the contents of this file, and we're going to look at the file tracer. Now this should really be a non-breaking change, so we just want the exact same logic we've got here. So we'll take all the includes. We probably don't need that comment, to be fair, but almost everything else is as is, because we believe that's actually a file trace that we got here. And then what we need to do is we need to say, well, okay, wherever you see the word tracer, try replacing it with file tracing. And that kind of gives us a file tracer. Now of course you're going to say, but wait up, did we not say we don't want templates? That is correct. We don't really want the file tracer to have this notion of I/O. So what we have instead is constants to. So first, we don't really want this chap here. Second, we want constants to string input, which means that these functions don't need to be templates anymore. So they could probably be moved to the CPP, which we'll do in a second. We'll just keep track of this to the string. So whenever we have the word I/O, we want to get rid of. And hopefully what this will give us is a nice, clean class that just deals with files. Similarly to what we've done to the HPP, we need to do a similar exercise for the CPP. Quite literally needs pretty much everything we got in the tracer at present. So if we just go up to, well, I wonder if where is this anonymous namespace finish? Just here. So all the way up to here. And interesting, getting a bit of errors there. Didn't expect that. Cold is not quite fixed, sadly. And similar to what we did just now, we need to replace what we'll do this time, which is would say colon to make sure that we can just do everything. And now we just pick up whatever remnants, because sometimes we end up updating things we shouldn't. So now we can do this by hand, which is just 1 or 2. This was probably actually not the best idea, but Clang is giving us an idea where the errors are. Okie dokie, so now then, we just need a few minor updates here. So we're a file tracer. All the errors seem to have gone now, so that's good. And then for good measure, what we'll do is, again, like I said, it's incremental. So what we'll do is say, can you compile this file? And if you can compile this file, it's just another bit of work that we've done here. It's ready to be shipped. You can say tracing copy across tracer contents to file tracer. Right, and again, like I said, an assertion here, we copied across, okay, easy to check. Now, the second bit. Now you can see how sort of deliberately incremental this work is. We literally copied across, but we didn't do almost any change. Now, in the second step, let's look for make. just with our make path, we will now move the functions that we had not inlined because they were templates, that we had put in header because they were templates. One of these, and then you can see quite clearly that we have each commit. It's got one role only. That's an important thing. So the last start chain. So when we go through history, we should really be very easy to understand what it is that we're trying to do. I guess you'd call my commits almost OCD-like incremental. I quite like that. I think this is a feature, not a bug, but other people disagree. But I do have a rationale for it, and the rationale is that I don't have infinite time. I have very limited time to work on this open source project. So any time that I spent trying to figure out why something wasn't working is time that I don't spend creating new things. So I don't really want to spend much more than, well, as little as possible basically when things break. And by having extremely incremental commits, I find that I can troubleshoot much quicker. I also am not a big believer in squashing commits and things like that. I think history is there to help you, not to look pretty. So squashing is, in my mind, not as helpful as it may appear in the first place. Of course, if you are in a large team of developers and the commits are communicating, is a form of communicating with lots of other developers, maybe then you have to treat the history a bit differently. I understand that. But if you have an open source project and you're working just with a small team or just you, then the same kind of problems don't really apply, so make UAC work for you basically. Okay, that's screen 2 as expected. Now with this commit we simply say tracing in inline, I guess, methods and file tracer. Righty, so then what we're now going to do, because we think that all this tracing should have been as is, we're going to do something slightly more challenging. We are going to forward all the calls here to our new tracer, and we're going to have the state of a file tracer. So you see the idea here now is that you are making use of the file tracer instead of implementing things yourself. So first we just put the file tracer here. Just call it file tracer for now. And then of course the file tracer will require some kind of initialization. Right, so now what we're going to do is we are going to say let's gut this guy. So we need a configuration. Oh, actually, seems like we are accessing the configuration, so for good measure, let's just say we keep the configuration. Righty. So each of these methods we want to say. Interestingly. So as you notice here, we're basically saying if detailed tracing is enabled. Now, this actually is not a file tracer thing. This is a tracer thing. We could let the file tracer always write and let the top level tracer handle this. So let's just, for a second here, How do we determine till tracing is enabled? Right, we go to the configuration, right? So I think it's fair enough for the top level tracer to remain to determine whether it's needed to trace or not. Seems like a logical thing to do. Perhaps validate as well. Yes, we're validating the configuration. So validate tracing enabled. Now, we don't want to do any of this. We don't want to do any of this. In here we want to basically say add additional inputs, so input ID and inputs. So as you can see, we are just forwarding the logic of the work itself to the file tracer, and the remainder of the work will be very similar. Interestingly, we are calling start chain. So some of these methods may not make a lot of sense anymore. Let's just persist with our approach. Start chain. Well, we need something that's very similar, so inputs and similarly start transform. Oops, start transform. Inputs. As you can see, this is not particularly creative exercise. We just have to make sure we call the right methods. So I'll trace another pointer and chain, and then outputs, and then notice that we cough again. And transform your inputs, outputs. Righty, so hopefully, if I could spell, hopefully this is making sense now. Now, of course, we don't want the matrix builder, also positions, and all of these. So as you can see, this tracer now is just basically a shell that forwards work to the file tracer. So we probably can get rid of a lot of these things, right? So we don't even need optional. Yeah, optional, we do need a map. Yeah, we do. Stack, no, we don't need a stack. List, we need a list. Path, we don't. Configuration we do. File we don't. Matrix we probably don't. Right, so as you can see, this is much simpler now. Right, so in here, what we want to do then is we want to say almost all of the logic here is going to go. You can retain the log, I guess. And we don't really want. In fact, I'm going to go as far as saying let's just include that for starters. And so what we're going to do instead is but as you can see, there is some bits of validation that we are doing here that need to remain. So what we'll do instead is we'll just copy the things that we removed that are no longer necessary. They are no longer and well, they are necessary still. You just copy them by hand. So for example, directory missing seems like a useful thing to do. Tracing error seems like a useful thing to have. And, probably a throw exception. Very nice. Tracing enabled. It's good too. Still tracing enabled. Okay, so and output directory. Now, I actually don't even want that function altogether. So handle current directory. That seems very file related. Shooter from position is not empty. Full path for writing. Full path for writing. Make path. Lots of file related stuff. Add references graph. Now in here we want to call the file tracer. Keep calling this as a pointer for some reason. So roots vertex. One thing would be really nice is if LSP was clever enough to instead of giving me a full signature, just give me the names of the parameters. Deduce them from the context. One day we'll be able to do that. We seem to need empty as well. Now I'm sure that this logic at the moment of the calls to start chain and so on is not quite right, but for now we're just gonna have to go with it. So file tracer, start chain, transform ID, model ID. As you can see, this is not very creative really. All we're trying to do here is to ensure we got exactly the same calls. And the net result of this hopefully will be that we're not breaking anything. Hopefully. If we done our job properly. And transform. And tracing. Of course, if you make any mistake here, it will really cause problems. So, well, it doesn't really matter. We can just say return false. Doesn't matter. This is just because we're using this in the context of a data object. Right. So, I'm gonna actually not think too much about this and just see what happens. Okay, problems. So tracer.cpp. Start from the beginning. So seem to be missing some functions in our file tracer. And chain. So the first problem we have is in line 111. So we seem to have an end chain output. Ah, okay, this is interesting. Right, so okay, this is where things start becoming interesting. Right, so this is exactly what we would expect. So now, if you remember, here we have a template, and this template we know for sure, well, this is the contract that we're making, it must be IOable, it must be convertible to a string, but it isn't a string. And then what we're doing here is we're then calling, with that T, we're then calling something that requires a string. So what we need to do now is we need to, for all these methods, we need to ensure that whatever the logic that we had. So for example, if I go to end chain, you will see that end chain, this version here, you'll see that the first thing it does, most interesting, it goes to file, right? So let's have a quick look what this chapter is. What we'll see, of course, is this thing here is converting using a string. Is converting to a string. Now, this was actually quite nice because it meant that we could do everything in one go. So we just did once as we wrote to the file. Now this is no longer possible. Well, it is possible, but then we have to replicate the same logic of maintaining the file backend as a template. Which, to be fair, may not be the worst idea in the world, because if you remember, there's different requirements for the relational model versus the file-based backend. For the file tracer, we will use strings, but the idea is that the operator extraction or insertion, I never quite remember the names, is defined against whatever object, against whatever target. And then here we're just propagating this notion of an IO all the way to the point where the operator inserter is called. For relational, we resolve the type much quicker. We have to call the adapter. So the logic then would be that in here we'd have an if backend equals tracing, if backend equals file, then, well, just call end chain. And this guy could live with a template. So in effect, really, what we've done a second ago was a mistake. This is another reason why it's good to have incremental commits. It's much easier to undo. So what we'll do is we will leave the changes we've done to tracer because that looks good, but we will uncommit the last commit, which will then take us back to having inline methods with IO. See, this is another good thing about doing very small incremental commits. It's much easier to undo and redo. So we will keep this as it was, and we will allow the file-based. So what we're now saying is actually having a template is not a bad thing. It's just only applicable to files because of the whole string logic. So we will do that, and then, as if by magic, we might just get away with compilation working. No. So in the file tracer we're calling end chain with output. Now it's not so obvious why that didn't work. To me that seems perfectly acceptable. Oh, actually, sorry. You're looking at the same file in two different buffers. Right, so, okay, right. I thought we just undid. Okay, so we undid the commit, but we forgot to actually, so obviously what happened was that the commit is now in, the file. So what we want to do is to say remove those changes. Right, cool. Okay, excellent. Now let's look at this. So I think what happened was we've already removed. Yes, we've already removed the templating support. So that's fine. So let's just look for the word template here. And for every entry of template here, we want to put it the way it was. Initial inputs. Hopefully we're still following my logic here. I want to preserve the approach where we are using templates for the file-based backend, but I don't want to have that approach for the relational model, because for the relational model that's not going to work. So if we just go back to where we were, the delegation should work. And chain to this chap here. Software engineering is, and now you can understand why I'm so keen on doing things versus thinking about things, because I think that it's very difficult to finer points of coding are to do with implementation. It's very easy to sit down and have all sorts of ideas and, you know, talk about coding, but it's very, very different from actually doing it. It's one of those activities in life where doing it is qualitatively different from thinking about doing it. Now, interestingly enough, we seem to and transform and tracing. Okay, right. So I wonder if this would compile, because now we are forwarding all the calls. Close. So tracer.cpp 24. Sorry, that's not quite what we wanted. Let's just include 52. Okay, I know what the problem is. The problem is that we are probably trying to do some dumping of optional. Of course, we're not quite out of the woods yet, because there's still lots of duplication between the two backends. But we just need to get this thing compiling again. Let's have a look at how long we've been recording for. Almost 2 hours. Sadly, the tracer is a very used file, so whenever you change it, it triggered a lot of changes. Okay, cool. So that's not too bad. What happens if we try to run the tests? Okay. So okay, terminate call recursively, right. So it's probably, what's happening here now is that we probably are, and this is what I meant about the logic of the calls wasn't entirely right. So I think what we're going to find is that the way we are calling these methods is not really the right way to do it. Let's think about this for a second. So this is probably fine. Now this is interesting. So we're calling start chain here. And so this then results in a call to file tracer.start chain. So it's not entirely clear to me that we should be calling start chain, because remember, we are inside of file tracer. We're doing the same thing as we were doing before. So to me, what we are really trying to do here is to say, just call file tracer and let it handle it. And so that would then mean that for all these chaps, and then the other thing as well, of course, is remember, we should not be calling main chain from here either, right? Because again, the file backend is doing that, file tracer. So we just have to make sure that this doesn't result in some kind of recursive madness. So validate C looks good. Tail tracing enable looks good. Add reference graph looks good. Start chain now. If tracing never returns, start chain. Okay. File trace. Okay, now. So if I call start chain, really, let's just now make sure we just forward everything. We probably should really be looking at the logic of this in detail, but I'm just trying to see if there's a way to just do this without thinking too much. Again, we're gonna have a massive build. Talking about builds, what's our current state of the world? So Dogen is looking quite nice. Windows, of course, is taking its time. But that probably implies that we are done with the impl, which we are. Yeah, this is all very nice. So perhaps tomorrow we will have concluded the work in the builds. Everything should go green. It's quite satisfying. Okay, we still have our Sega boards. I wonder if what's causing the Sega boards is that we created a cycle in tracer. Just make sure we didn't do anything silly here. Be nice to get this thing working before we start modifying any further. It's not entirely. Oh well. One thing we probably should be doing before we go any further, while we are thinking, is kick off immediately a debug build, because sometimes it's just quicker to have a look at the debugger, because it pinpoints to the place where we're being silly. Meanwhile, it will take a little while for that debug build. We will just have a quick thought experiment as to what we're doing here that's recursive. So I think the problem will definitely be one of these methods where we're calling start chain and then calls something else, right? Our job right, everything should just be about forwarding to the next guy. So really not much space for recursiveness here. Let's look at the CPP. Most interesting, we seem to be having the following problem with the Trimax problem recurring. I probably should just do an update in case Alexander has released a new version of Trimax. We haven't done that for a while. Just for good measure, let's just switch off follow mode and enable it again. Sometimes it's no, still looks a little bit out of whack. I wonder if I need to close and open the file. No, still. It's peculiar because it was actually working okay. Now it seems to have recurred. It started with the org mod files and now it seems to be yet again causing problems everywhere. I'll have to report that back to Alexander. Okay, so we are having a problem with recursion. We must have just done some copy and paste error, and that copy and paste error probably was done as we called the file tracer. I'm pretty sure we ended up calling the wrong call somewhere here, and that's why I wanted to make this very slow and steady, but clearly it wasn't slow and steady enough. Start chain. Ah, interesting. What's this? we are calling a different method here. It's very important that we call the exact same method. You can see we are not. This can't be a good thing. Must be exactly the same method. Okay. Okay, our debug build is done, but actually I'm just going to switch back to release for now, and if it happens that this doesn't fix the problem, we'll just rinse and repeat. Okay, it didn't fix the problem. Let's go back to debug. What we'll do is we could measure. Let's just create an area for debugging. I find that GDB is not particularly brilliant with workgroups in Emacs, because GDB generates a lot of windows. Sometimes I even wonder if it's not better to have a frame just for GDB. You can use it there and then just get rid of it. But this is probably running the test, and pretty sure the build was completed. Now it's probably going to start building other stuff that we don't need for the test. So what we'll do is build output. So if we jump over to the debug clang stage bin, and here you would find that there is an engine test would be here somewhere. There they are. And then what you can do is you can just say GDB, and then this guy here. Now I vaguely remember having some settings here. GDB with my windows were all available, but settings like stacks and stuff like that. I think I may have lost that settings. So I'm actually just going to be lazy, just literally just do a run. Okay, that's not possible. So we need to tell it where the projects directory is. Let's try again. Oh, clearly we need to tell it about all the different directories. So this would be something like tpd ref import master projects. If I could measure, we also need to talk about the C# ref import, which is source, I believe. Perhaps not source then, clearly. Let's have a quick look. Oh, I forgot the branch. Okay, cool, no problems. So let's just take master, it doesn't really matter. Right, this is already a bit of a long video. Right, as you can see here in our backtrace, this is going to tell us where recursion was happening. And we seem to be calling operator bracket brackets, operator call. The problem is scoped context manager. Let's have a quick look at this frame 6. Now you can't see what I see because it's in a different screen, but so the error is coming from, let me just this is what I mean about GDB requiring too many windows. It starts opening windows all over the place, and then it's difficult to right, so if I just open up the scopes context manager, okay, so GDB just insists on putting in a different monitor. Rather annoying. Let's try again, but I must say I find it quite difficult to get GDB to behave in Emacs. It just doesn't want to listen. It's very difficult to just get GDB mode to do what you want it to do. It's best to just not fight it and just let it do its thing. So sorry, you won't be able to see what I'm doing at present. So I'm looking at Scope Context Manager, where GDB is telling me on line 35, it's telling me that something has gone wrong. What exactly is it? So the structure of the Scoped Context Manager is being called, but then attempt to call end tracing. It tends to call end tracing, and then end tracing. See if I can just go back. Oh, the other thing as well that GDB does so nice is to change the key bindings, which is rather annoying because I don't even know the key bindings. I don't know what functions the key bindings actually call, so I can't actually change call the function manually. Right, so what we're trying to do then, we're trying to figure out why would end tracing be a problem? It seems, let's just see if there's any null pointers here. Clearly must be calling a injection context.tracer. I wonder, well, let's just have a look at what the tracer does when you call end tracing. Maybe that will give us some clues. Well, it calls file tracer.end tracing as expected. File tracer.end tracing writes the metrics. But the key thing is we haven't even got that far yet, because as soon as the instructor gets called, the call to terminate comes in. Now, just for a laugh, what would happen if, because remember, one thing we did, okay, I'm just going to stop GDB for a second, because sometimes GDB is just too painful. I can't use Emacs with all this faffing around with my key bindings. So I'll just put our screens the way they were a second ago. So this is what I was saying on the other monitor. So as you can see here, end tracing is being called from the tracer. In fact, let's start with the scope tracer. So this guy here is the last thing we see in the debugger before terminate gets called. So tracer.end tracing. We don't actually see a call to the end tracing. But as you can see here, we double check that tracer is pointing, so it's actually allocated, and then we call end tracing, right? Now if I look at tracer, let's just make sure there isn't more than one end tracing call. Here's the one. If I look at tracer, it says finish tracing. Tracing was enabled. File tracer, if the tracing wasn't enabled, go out. Otherwise call file tracer end tracing. And file tracer and tracing is this chap here, and it should then start writing the metrics and so forth, right? Nothing particularly special, nothing that would make you think twice. So So I don't think this is very obvious. What we'll do instead, given that the debugger didn't really help very much, let's just have a quick look at what the log file says. Sometimes the debugger is not particularly helpful. So we'll just enable all the tracing. We'll just build a release binary. And then we can just generate a simple model, like say, actually just pop up into compilation. You can create something like Dogen, very small model. This is, oh, most interesting. Rather surprisingly, that actually worked. Okay, let's try something slightly bigger. We're expecting some kind of a explosion here. Okay. Not entirely clear why the tests are failing if the binary works. Okay, I'm going to have a quick look at these tests because, well, actually, before we do that, maybe it didn't explode, but maybe it didn't do anything special. So let's, before we conclude that this was a successful thing, let's just look at what the tracing of assets looks like. So the log looks healthy. The assets report is here. Shows us everything that Dogen thought it was going to do. Tracing looks healthy. As you can see, the dates are all today. The plot thickens really. Tracing worked really well actually. Surprisingly so. That's today's date, 16th of November. This is extremely puzzling, so it seems like it's more of a problem with the test itself. Let's see how the test is using the tracer in case it's doing something really silly. So, byproduct generation tests, line 304. Let's leave this here in compilation so that we so byproduct tracing, byproduct generation, sorry, line 304. So according to this, let's also see if we can get some so we can do this when we're trying to get some more information about something that's gone wrong in the test. What we can do is we have these utility includes. So if I go to say logs, or even tests, I can't quite remember. Logging. We have a macro of some kind. Oh yeah, just had the word debug it seems. So let's just go back to whatever we were. 304 was it? This guy. And I think if you just type debug here, and then, well, we know these are just Dogen engine tests, so let's not run out every single test. So now if it all goes according to plan, this guy will write some logging for us. And if I now just go to build, output, clang, release, and these logs are in bin, pushing back byproducts, and if I look into byproduct generation, and enabling summary tracing. So the test suite is byproduct generation tests. should be looking for enabling summary tracing with plain text. I can't quite remember. Oh yes, it's because we're looking for the logs. So I think for some random reason I think our logging is, yes, this is very, very confusing. Right, so let me just double check we're looking at the right place. 1812, 1840, that looks right. Okay, what does the log say? Okay. We should have probably started throwing. So this is good, the test is actually doing something sensible. However, I'm not quite sure why this recursive started, but so as you can see here, it seems that we seem to have broken the logic. This is very hard to explain, given that it works fine for I wonder if, because the file tracer is in the stack, well, maybe this is something related to the ownership model of tracer. So let's think about this for a second. So tracer as a boost optional, and this is in the stack. So the theory was that because everyone is referring to the tracer as a pointer, we would never be copying the tracer. So the file tracer would never get copied across. So in theory, we wouldn't have to worry about whether we are the same or whether there's more than one of us. However, presumably, this test, we may be doing a slightly different use of the tracer. Let's just have a look at how this guy in 304 is setting up the tracer. So tracer is created around here somewhere. Let's just look at the test a bit more carefully. So there's a model, there's a type of tracer, summary, plain, configuration, remove the byproducts directory. We apply transforms. Now, what do we mean by apply transforms? So, scope context manager. Presumably, the scope context manager must create the context. And then here we apply transforms. And from here on, the use of context should be very much the same thing as we do in the main binary in this test. So I'm not worried about this bit, I'm just worried about this bit here. What was this guy? Sorry for that. So this guy here goes to the context factory, calls make context. So let's just make sure that there is no copying going on here of context. No, this is a bit brittle, of course, it's not ideal, but so context is created here. Now, context will contain a pointer to the tracer, so that's good. And then the rest of the work is in the test. And then here, we then enter the world of transforms, which is the world we know is common between the two. Why is this use different from the other kind of use? But before we do anything else, let's just prove Maybe this is just not really, just so we see what's going on here. I'm just going to do something like boost share pointer HVP, and I'm going to call this boost share pointer of file tracer. The objective here is going to be, maybe I was predicting something when I started calling file tracer pointer a second ago. Boost make shared, something like that. And so what I want to see is what happens if I don't know, something like boost make shared. File tracer. CFG. Okay, what will this do then? And then, of course, we need to oh, well, we must have done, we must have somehow forgotten to close the buckets. Alright, cool. Now we're gonna have a lot of problems with file tracer. So, file tracer dots. Same thing here. Now, you may say it doesn't make a lot of sense for us to be doing this. Sometimes you have to have some, how should I say, intuition as to what the problem is. Peculiar, but there is some logic to the madness. I think what's happening is that somehow we must be. I know that in the past that we were copying the tracer, and the logic in the tracer is not designed for copying. Can't quite remember exactly why. Whenever you do this copying, something bad happened. So the solution we had for this problem was very simple. Whatever the tracer is used, which is a lot, we just created this context for all the transforms, and you see that it's always a boost share pointer of tracer. Now this guarantees that the tracer is not being copied around. No, okay, good. The error is still occurring. But interestingly enough, either we didn't notice that this error was there before, or okay, that's interesting. Okay, that's good. At least we've kind of proved that it's not the share pointer that's causing the problem. Let's just go back to where we were. So if it's not the share pointer that's causing the problem, then actually, to be honest, it's actually easy to just fix this manually. And we don't need to make sure anymore. Okay, right, so we do not think anymore that the problem is related to the share pointer, right? What I'm going to do now is, excuse me, let me just rerun this test and then make sure we can see the error of the mismatch. The error only occurs in tests. That's most peculiar. Something special we're doing about the tests. And this is what I find interesting. The most interesting thing about programming is that almost never is the case that the problem is where you'd expect it to be. I mean, I thought that this would be a trivial thing to do, to just come here and update the yeah, okay, so we just missed the error altogether. The error was there, it was quite good. The tracer was actually trying to tell us there was something wrong. And then the throw made us think about recursive, I don't know why. So what's happening then is, and if we return to our log, not quite that long. I'm sure we had a log like 5 seconds ago. We have several logs, but none of them seem to be the one we want. So this is the one. Okay, so okay, fix me here. Interesting. There's something called Dogen. Started multiplex transform. Started. Right, see, no transform started at present. It is almost as if we made a mistake in the order of the calls. For example, this could be explained if the file tracer is wiring a different call. So this is where really we need to be very careful. We need to make sure we really are calling the same calls. There's a very tiny mistake here. It's really not ideal, but there we are. So what it seems to be the case is that the start transform is not kicking in. So let's just double check that the start transform still start chain, start transform, transform ID, and then start transform with 2 parameters. So what happens if I call start transform without any parameters? Is there such a call? No. So, and of course start chain, no parameters, there wasn't one either. So let's just double check every single one of these is correct. They look fine. So on the other side, let's just double check that we are doing the right things. So start chain. I mean, it's hard for us to have done a mistake here because of course we just copied and pasted this code, so but you never know. Since we don't have any start transform, start chain. I wonder if we removed one of these lines here. Oh, so it looks alright. It's extremely pleasant. And also on top of that, this video is also already becoming quite long, so I think I might have to call it a day. So start the C++ model text transform. Starting MASD.generation.cpp. The logic error. No transforms at present. It's interesting that we start C++ model text transform, and the next thing is we attempt to be. So let's just have a look here. What do we mean by logic error? So this is not. Oh yeah, of course, it's in the builder. Logic error, no transform started at present. So the builder is attempting to build. But why would the builder be building when we just started a transform? Really, the only point at which you call builder in the file tracer builder current, okay. So we're handling current directory. I have to return to GDB, but before we do that, see, it seems to me that we must be around here somewhere. Builder starts. Must be around here somewhere. And somehow we seem to somehow very quickly go from starting to finishing. So let's just see where this unexpected gets thrown. Ensure stack not empty. This is probably something the builder does a lot. Okay, update ends. Start. Okay. So the very first thing the builder does on start is ensure the stack is not empty. Okay. And what is ensure the stack is not empty? Stack.empty. So when would the stack not be empty? Let's just look at all these operations in the stack then. Right, as you can see here, stack push. It's a very first thing the builder does. So let's just look very carefully at this metrics builder. This seems to me is the key. And so if I just go to log view mode, so interesting enough, the stack builder is doing all sorts of things. So it initializes, and let's just make sure that we are visualizing the side by sides. So it initializes as you'd expect. Seems to be pushing and popping nicely as you go through the transforms, and then by the end of it, it finishes with a stack size of 0. So that kind of is the behavior one would expect to see here. However, the interesting thing, of course, is that we seem to start doing all over again. So starting MASD.generational CPP, this is probably a top level. MASD.generational CPP is probably a top level transform. It's good that we have all these errors really, because if this was just kept going without throwing, we would never know. What we need to know though is we need to figure out, just go back to that test. And do we run the transform more than once perhaps? Could that be causing the problem? It seems like we do it once on each test. Kind of would make sense. Yeah, so we do it once in each test, so it's not as if... and we recreate the context for each time. So that looks good. So you can clearly see here we are ending root. So this seems to imply that we think that everything's finished, but then somebody goes and starts something. It's not very obvious why that would be. So what we'll do instead is we will just say, show me what happened around the time so as you can see here, matrix builder is very happy up to now, but now we enter some assembly validation. Okay, post-assembly validation. But see, if we're in post-assembly validation, we clearly are not at the end of all transforms, right? We're still in the thick of it. This is, we're still halfway through the transforms, because this happens inside of the, deep inside the pipeline. So after validation, we still have to do loads of things like generation and so on. So we wouldn't expect to be at 0 already. See, now you can see here we're going through all the transforms, but interestingly enough we don't seem to be going via the matrix builder. See, all of it is making perfect sense around here. We keep going. That gets pushed in pop as we go into the. And then here we end transforms.assembly chain. Now, just to see where we are, if I go to assets, I believe we should see that the assembly chain. This is the post-assembly chain, pre-assembly chain, and there's the assembly chain. So we're still deep into the pipeline. Model production chain is the end of the assets. So it's a bit weird that we already are stack size of 1. Seem to have got there. So if I just go back. So we seem to have ended rooted it too prematurely. Why would we have a mismatched number of starts and ends? We have done something, I mean it's clearly the case we've done something with file tracer that no longer follows the symmetric logic that the tracer did. Difficulty is understanding what. And this is why it's important to do small incremental changes, particularly when your brain is no longer functioning after a long week at work. You need to find a way to diff a file tracer. Basically, because of this, we have a mismatch between starts and ends, and sometimes you just can't see, right? You're looking at the files, but I mean, this is here clearly. We must have done something where we're calling end where we should be calling start or something like that. So we just have to look very, very carefully. Start chain. It's definitely start chain. Transform ID, model ID input. But then, why would it work on a normal code generator? That is peculiar, isn't it? Why would it? What's so special about this test? That's the question we're asking here already. The test must be doing something different. It's causing the calls to be out of whack. Nevertheless, let's just keep looking. So transform, end transform, end chain, start transform, same number of parameters. Start chain, add initial input. Okay, this looks, can't really see any problem with this. So add references graph, start chain, 2 parameters, start transform, 1 parameter, start transform, 2 parameters, end chain, end transform, end tracing. That looks absolutely spot on. Let's try the file tracer. So what we're looking for in the file tracer is perhaps in fact maybe what we can do with the file tracer is we can diff the file tracer with the previous tracer. This should be rather identical, shouldn't it, really? So if we just take the tracer and if we just ask Emacs to tell us what's heads looks like, and if we just take the file tracer header, and if we just ask it if buffers, I guess. So if we just do tracer HPP ahead against file tracer HPP, as you can see, edif is also looking rather strange. I wonder if I can just kill this guy here and then resize these 2 guys. We're having a lot of frame-like problems in Emacs of late. So, as expected, the name of the class, constructor name, just a space, operating concept. This looks very good. This is exactly what one would expect. Okay, and now, if we do the same exercise for the tracer.cpp, where we ask for the head, and what I'll do is, I think it makes life easy if I just do edif with the full buffer. So cpp and then file tracer.cpp. See, edif seems to work fine if you don't have any windows open yet. So that's fine. That's fine. No, that's fine. It's fine too. What we're looking for is some kind of logic difference. These are all just renames. Okay, good. So at least this is very good. So we know for sure now that we copied and pasted correctly, as you'd expect, but just double check. We didn't do anything silly in the copy and paste. I wonder if I can just do render and do Control C left, is it? Control C. And if I can just go back to my... Oh, there we go. So the copy and paste was not the problem. We can't see anything obvious either with the forwarding of tracer to file tracer. That also looks very simple and very correct. So we somehow appear to be missing, and we know for sure it's not a copying problem because we put a shared pointer here. That didn't make any difference. We just appear to be missing calls from the tracer into the file tracer. That's the only explanation for this. We just don't know why, but this seems to be the case. What could explain that? Tracing enabled could explain that. If for whatever reason we think we have tracing enabled but we don't. But why would it change halfway through a run? That doesn't seem very logical. What could cause that? And in fact, the other interesting thing is there's a mismatch between starts and ends. We seem to be ending too quickly. So this could be caused by end being called more often than start. So let's have a very close look at end. End chain, end transform, and tracing. So what do we do for... Well, we know for sure that the logic in file tracer has to be correct because it's identical. So yeah, this is definitely the case that the file tracer has to be correct. It's identical to tracer. The problem has to be with the current tracer. We've already proved that by the diffs. So if the problem is with tracer, let's think about this. Problem appears to be with tracer. Is there some variable here that we had before? So let's just have a quick look at the state of... Okay, not that chap. File tracer HTTP. So this is the state that we had before. And you can see why we don't really want to be copying things around here. For example, matrix builder. If it gets copied, we want to make sure that we have the same matrix builder across all transforms, because of course we're pushing and popping things into the stack. So if it happens that we ended up with a copy, that would cause problems. But we have proven that that's not the case by putting a share pointer. Perhaps what's happening is that somebody, somewhere, in one of these transforms is making a copy of the context instead of using the pointer directly. That could explain why making a copy of the tracer in the context and as a mistake, and then that will then explain why. And we should know, because if we look at the if we look at the log file shows us all of the calls to matrix builder. Let's see how much we see of the file tracer. Okay, perhaps we can just do a quick grab the file tracer, and then let's see if there's any point at which we have two file tracers. So starting, so 0, 1, 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 7, 5, no 7, 6, 7, 6, 7, 6, 7, 6, 7, 8, 7, 6, 5, 4, 3, 2, 1. So it seems well, I think this looks a bit suspicious. So let's have a quick look at all of these transforms. So let's keep a copy of these guys here. Just as a starting point. Oh, we are. Okay, so if I just have a quick look at well, let's just from scratch so we can dump all these guys here. So we start off by looking at all of these guys. I mean, they're clutching at straws a little bit here, but it seems to me that somebody's misusing the tracer. The thing is, of course, almost every call we've got is using one of these scoped chain tracers. This would also explain why it was that GDB thought that the problem was with the scoped chain tracer. Let's have a look where we were a second ago. Oh no, I thought it was the scoped context manager. Scoped context manager. Is this used everywhere? Well, to be honest, this is where sometimes one forgets that one has LSP. So yeah, we use it in generator.cpp, so that's actually main code. But interestingly enough, we use it directly in tests. So the scoped content manager is used directly in the tests. We're getting this into a bit of a wild goose chase here, but we just have to get to the bottom of this. It shouldn't really be that complicated. Perhaps what we can do to make our life easier is return to the file tracer, and every time we have a log, we could just write this. So C++ x 3. So stdx. Okay. So hopefully we should be able to just do this, and then when we log, not that guy perhaps, but perhaps from here onwards we probably need to include that on manip, which we already have. So what we're going to do then is, let's just do something like int this. So what we're trying to do here is okay, so what is long? Okay, we will just cast the pointer just to see if we can have some kind of idea. Of what's going on here. Every time you log something, just tell me who you are. hopefully this will give us some idea as to any untoward copying that may be happening. Which is still my theory, really. I know it's one thing we forgot to do is we forgot to stage this file before we did any changes, so now we're gonna have to manually undo them. You should always stage your file first before you start manually messing around, because then you can simply discard the changes and you don't have to be faffing around with undos and things like that. But there you are. Plenty of logging. Make sure we're not missing any of these. So with this, we'll be able to see if at any point we changed the pointer for this. And that would tell us that something is not quite the way you'd expect. And then hopefully that would also give us a place to look for that one change. Because as soon as we see the pointer changing, and of course you could do all these things in GDB, but you know me, well, should I say, dislike for using GDB within Emacs at present. It used to be actually really, really good, but somehow with all these modes of work groups and all kinds of integration, it seems that Emacs just is not as usable as it used to be, GDB in Emacs. Okay, so now what we want to look for is the file tracing. So tracing. File tracing. Okay, we forgot to put a space there, but not to worry. Hopefully, we should see the same number everywhere. Most excellent. We see exactly the same number everywhere. I forgot one of the logs, but it doesn't matter. Yeah, exactly the same number everywhere. So there is no copying happening here. It is the same tracer. Okay, good. Right then, so as I said, because we didn't do the right thing, now we're gonna have to undo all the way back to the beginning. Then we should have done, which is to stash, not stash, to stage the file. We could just discard the changes now. Such is life. And this is the last. Okay, good. Okay, so what other ideas do we have here? So we are not making a copy of the file tracer. The tracer works perfectly well. Actually, one thing we didn't do when we generated the traces, I don't think we built the latest Dogen. It would be much, much better if Dogen is blowing up as well as the tests. It's very puzzling as to why Dogen works, the tests don't. Much more reassuring, Dogen also didn't work. But sadly, it seems to work perfectly well. It is definitely something specific to these tests. We're going to have to understand these tests in very great detail. Trying to avoid that, but it doesn't seem like there's an alternative. Something special about the tests and how they're interacting with the tracer. So we've been recording for quite a while now, almost 3 hours actually, since the longest video. It also seems to be the most, well, the least productive at present. this kind of debugging is also very difficult to do while recording, actually, because you can't really. It's difficult to focus while talking. This kind of problems you really actually need to be in a quiet isolation. But we'll try our best. Okay, so test over failing was 304, I believe. Set up the tracing configuration. Apply transform. So the difference between Dogen and the test is that we are entering the transform pipeline from a different place. As you see here in apply transform, we create the scoped context manager, which, as we've seen in the reference, also happens in the real world. Now in this case we seem to only do that inside of generator.cpp, which is also quite interesting actually. Why is it so low in the pipeline? I mean, generation.cpp is actually quite close to the end of the pipeline. Why do we create the scope context manager so far down? You expect it to create something a little bit higher up. Chain. These are tests. These are tests. And this is the real thing. So it's not very obvious to me. Ah, okay, it's just because generator.cpp is the top level class. Okay, I understand. This is actually the container of the pipeline. And we then create the scope context manager, and then we start the transform. And in the tests, we create the scope context manager, configuration and output. We supply the context, just like we do that. And then we call the extraction model production chain, which is a little bit further down from the code generation chain. So presumably the code generation chain calls that. We just open up the engine to double check. So you should see here the extraction model production chain here, and the code generator exactly. So as you can see, this chain here is at the very top level. This guy, the generator we just saw, calls the code generation chain. That then calls the extraction model production chain. So we just bypassed that and went straight to the code generation chain. Reason being probably that the code generation chain then starts doing some writing, perhaps. We probably don't need that for the purpose of this test. So we just need to create the extraction model. We don't particularly care. Interestingly enough, we seem to have some scope. Just out of curiosity, I mean, this makes no sense at all, but just out of curiosity, what happens if we create some similar scope here? I don't think this makes any difference, but we're just trying to see where the differences are really. And yeah. Still have the same problem as expected. This is not really an expected fix. Right, so apply transform. Go to the extraction model production chain. Interestingly, I wonder if there is some kind of bug Now, but then again, we must remember these tests were passing before we done this change. So clearly, whatever we done is what's causing the problem. There's no two ways about it. Clearly, this change caused the problem. It was working just fine. So what we need to do to prove this is to say, so if the tracer was working prior to our changes, what could have happened is that when we were removing, let's just look at the diff. Now we know for sure that the file tracer is very much identical to the tracer, that's good. But now, what about the tracer? Did we remove too much? Did we, when we were removing things, did we remove something we didn't meant to remove? So if you remember, we decided that we didn't want to be calling start chain as well as start chain in the tracer, because the idea was you always forward. Okay, now this is interesting. So let's think about this for 5 minutes. In the past, when we called something like, say, start chain, this guy here, this guy would then call start chain. Now, when this happens, we don't call start chain anymore, but we call file tracer start chain. That then in turn does its delegation. I wonder if we change the logic in a subtle way, very subtle way. For instance, notice how, yes, we have changed the logic. This is it. Okay, this is it. I got it now. So observe. This is to be easier to detect, but observe how we were calling start transform regardless, and now we're only calling if detail tracing is enabled. And that's just because we changed the logic in a subtle way. And now this is a bit dangerous, because like what you have to understand now is that any of these cases where we no longer calling these methods, it's sufficient to get things out of balance. Now it's not necessarily the case we just want to call file tracer start transform, because remember, so you just have to be careful here what we're trying to do. In the past we called start transform regardless, and then if detail tracing was enabled, we did the dumping into the file. Okay, so what we're trying to say is that the easiest thing to do here is, let's not check, I mean this is not really ideal, but let's not check for detail tracing at the top level, because for this to work we'd have to make sure for every call that we had before, we have to make sure that it reproduced faithfully the logic that we had before. So the easiest thing to do is to just delegate and let the file tracer decide whether detail tracing is enabled or not, because remember we'd copy the whole logic as was. It's not entirely clear why the real the Dogen is not failing as a tester failing. It should really. Must be just by sheer luck. It may actually be that we're not using the same version of Dogen. I mean, this is a bit puzzling. It should be failing. So we use the release version, and we're building the release. So we definitely have latest Dogen. I mean, I have no good reason for this not to be failing, because clearly we changed the logic. Okay, so what we're going to do is, let's do two things. The first thing we're going to do is, let's just first get this working. And to get this working, what we're going to do is to say, forget about checking, just delegate. Okay? Now this is not the right fix, because of course now the problem is every backend is going to be doing exactly the same logic. Of course that's not ideal. So what we do is we do exactly the same thing. We just want to get the test screen Right. Oh, interesting. Very interesting. Most interesting. Oh, so we have two bugs then. Most interesting. Somehow we did not see this. This is what I mean by when you spend too long looking at a code, sometimes you just don't see things. This was a clear problem. So we had two problems. One, we changed the logic, and the logic was that in the past certain operations were not conditional, and now they became conditional. The second thing was just a really silly typo that somehow we missed 20 times. It's very, very strange, but there you go. We also don't know why it is that the code generator is working perfectly fine when the tests are failing. Okay. Right, excellent. So now as you can see here, what's happening here is that our code generation tests are failing because we generated some new files that shouldn't be there. So if I just go to tracing, I think we'll see this both includes as well as source. Now if I just go back to compilation and run this again, now this should fix our problem. Right, excellent. And let's run all tests. What we've done now is we delegated all the, I mean this is had to work clearly because we delegated all the calls to the file tracing. You know, the file trace is identical to the existing trace. So sorry for this wild goose chase, but it was actually quite an obvious thing in the end. Now, what we want to do is we want to make sure that if we build a code generator and if we enable tracing, let's just double check that we have enabled tracing. Tracing is on. We detail. If I then just go to code generator and then say generating every single model with full logging, full tracing. I mean, don't necessarily need full logging to be honest, but full tracing is definitely a requirement. Right. Didn't collapse, which is always a good sign. This is sadly the life of a program, I'm afraid. These kind of massive, unexpected problems. Right, now, be careful, just notice that these are convert targets. I always make this mistake. We want to look at the generate targets. Okay, so as you can see here, the tracing, didn't mean to do that. The tracing looks very healthy. All of it dated just now, 7/11. And it looks very good. Okay, so all we've done, although it took us 3 hours, is we, doesn't look like we've achieved much. And sadly, this is the real life of development, really. But we've copied the logic of the tracer over to the file tracer, and for now, we're delegating every single call. The next thing, of course, will be to create the relational tracer and start adding methods there. What we really wanted to do is to have the logic of whether to trace or not in the tracer rather than individual backends, so that we don't have to duplicate the logic. So what we'll do is, we'll do this in 2 steps. First, let's just make sure we are updating. Well, to be honest, this is also clearly the case that this sprint is going to terminate before we get really into the relational model. So, sadly, that's the reality. So, I wonder if you can commit this in 2 separate commits. Tracer. Interestingly enough, we don't see. Oh, okay, fine. So we should say something like tracing make file tracer inputs and output, templatize, or templatize really, file tracer, inputs and outputs, okay, and then we could say this we don't care, this, I'm not quite sure what this is, probably some update to the model. We could say something like tracing. Oh, actually, what do we call that? Commit segment tracing is correct. So tracing delegate all tracing tracer calls to file tracer, and we don't want to commit that. This we probably do want to commit. Out of curiosity, what happens if we convert Dogen dot tracing there. Actually, these models are synced. We're not having any breaks at the moment, but no, there's nothing that has a JSON representation, so that's fine. Just say models updates to tracing model. I'm a bit tired now, so I'm not actually coming up with the best commit messages. And then agile backlog grooming. Right, okay, cool. This video is already becoming rather long. We're already over 3 hours, so I'm not going to continue too much for too long. So we didn't really get very far today at all. All we were trying to do is to try to see if we could create a file tracer and a relational tracer. We wanted the file tracer to be more or less a mirror of the current tracer. We also wanted the relational tracer to be similar, except not a templatized version. And then what we wanted to do is start creating a series of methods called new_new, and those new methods will be implemented one at a time in the relational tracer. And the idea being that we could, one at a time, we could just start adding support for the adapters. So the logic will be that we'd have an adapter per model, and these adapters will convert, as you can see here, will convert the existing model over to a relational representation. And when we call the relational tracer, just prior to calling the relational tracer, we shall call the adapter via some kind of global function that's overloaded, and that will then convert it to a relational representation. Then the relational tracer will just connect to the database and just dump that model there. And that all seems quite doable. Sadly, the delegation, which was quite trivial, ended up being a really big problem, which took most of this video. So I'm going to have a break now and then probably continue with the work of the relational tracer. This is all for this part. Thanks for watching, guys.